welcome back to the Tin Barn. I'm Pragmatic Lee, and today's video is going to involve a few little fixes that need to be done on the surface grinder back here in the corner. I'll get pointed in the right direction in a minute. But this grinder is 41 years old, in excellent working condition, but there's a few little worn places on there that I think we can do something about. The first one, and the one that's given me most of the issue, deals with the chuck handle, the magnetic chuck handle. It started out as a 3/8 inch square stock, rounded on this end, that fit in to the engagement to engage the chuck and disengage it. First thing, it's missing the knob. That'll be simple enough to build. I do not have a radius turner, ball turner for my lathe that I've got now. I jokingly tell people that my little mini lathe, 7X lathe I had from Harbor Freight, I made a ball turner for it one time, but the only ball I ever turned was for the handle on the ball turner. So I've not taken the time to make one for the PM lathe, but we'll come up with a knob. So we're going to replace the handle, make a different handle. You can see it's extremely worn in here. The hole that the pin went in is elongated to the point of that spring pin. You can see that play. And also the collar that mounts on the chuck itself, it is wallered out tremendously inside here. I'm not going to try to remake this. Biggest reason is what holds it to the chuck has a tapered pin in it, and I do not have any tapered reamers. But you can see how much wear there is in this whole setup. To compensate for some of this wear, I'm going to set this up in the mill and use it was originally 3/8. I'm going to use a 7/16 end mill and open this up right here. So let's go over to the mill and get set up for that. I've got the body of the handle assembly located in or mounted in the mill vise now, and I've got a gauge pin that I'm going to use to locate that center. I used gauge pins to find that center since it's a little bit worn, and it turns out it's a .425. Now, to me that seemed like a kind of odd size, but in any case, that's the pin that would fit in it. So we're going to use that to center up with. All right, now I'm going to lock the X and the Y on the table right now to be sure that's and that's centered as good as I think I can find it. I'm going to zero out the DRO as well, and we'll take the chuck out and put the end mill in. As I say, I'm using a 7/16 end mill for this. Now I do not want to use this in the round part that goes over the pin in the chuck itself. So I'm just going to move out here a little bit. That is just barely scraping the back edge now. Plus the bottom set this on this plane. All right, right at the very outside edge is a part that it didn't catch on, but it did clean up the rest of the way in there, and it's cleaned up on center too. So while I'm over here at the mill, I'm going to see what size spring pins I got larger than the 1/8 that was in there, and go ahead and drill this hole out. Okay, I've found a gauge pin that would fit this walled out hole pretty good where the spring pin would go. I've got it centered up on that now. And we're going to go back with a 5/32 spring pin, considerably larger, but that was the next size up I had in my set of spring pins, or I had available. So we're just going to clean that hole out, and then we'll be done with this piece. All right, now we're going to get set up over there on the lathe to start turning our handle itself. Okay, you remember back in high school sitting there in your math classes, trig, algebra, or whatever, and thinking, I'll never need this again in my life. Well, guess what? We're going to use a little trig here today. We said we wanted a square shaft to go in our body that was 7/16 on each side. 7/16 is 0.4375. So we need to know what size round stock we'll need to mill off to get our 7/16. So if we go across the hypotenuse, and we know the formula from that, from our math classes, is the square root of a squared plus b squared. A squared, b squared. So 0.4375 squared plus 0.4375, which is 0.1914, plus 0.1914 is 0.328. Square root of 0.3828 is 0.6187. A 5/8 inch piece of round stock is 0.625, so that's what we're going to use. Something just a little bit larger. We'll mill off the flats. Before we go over to the mill, what I want to do is turn down about 1/2 inch of this and thread it. We'll also put a center in it for later. Get my DRO turned on and going. And what I'm going to use, I've got some 1-inch balls here that are threaded 1/4-20. I'm going to use one of these to begin with. If it turns out to be too small, I can always come back and turn something out of aluminum. This is some type of a plastic, soft, not soft, but it's kind of a textured material. But we're going to go with 1/4-20. All right, I was going to try to get my DRO up and going. We had a bad lightning strike here a couple days ago. It knocked out my wireless router. It's out here in the tin barn. Had a laptop out here. It knocked it out as well. And it looks like it has knocked out my DRO. The blue DRO connection block for that. So we'll have to do it manually this time and measure. But what I want to do is come back 1/2 inch. All right, now I'm going to set my stop there. And we want to turn this down to 1/4 inch and just a little under 1/4, and then thread it. So we got 56 thousandths to go. Be right back. I'm going to change that insert. All right, let's try our final cut on there now. All right, I've got the die guide in the tailstock now. We're going to see if it'll start on there. All right, now let me turn the die around to the finished side. All right, now we'll get set up over there in the mill and cut our flats. I've got the workpiece in the mill vise now. It is 0.625. We want 0.438, so the difference is 0.187 divided by 2 is 93 thousandths off of each side. I've zeroed out now. I'm going to leave about a ½ inch on this, on the end down here. I cut my piece 7 inches. The handle's going to be 6 plus the knob out here. So this will be to hold on to in the vise when we go back over there. So I'm going to take this, an end cut on this section down here, and then we'll start running back and forth. So let's just get a little cut there. All right, I'm going to try taking this half at a time. All right, I'm going to do that to the other 3 sides. Of course, touching off each time on the top, and then I'll bring you back. All right, I think there's a piece cut. If I have to take a little extra off, I will. Let's see how close that is. That's 440, that's 439 on that end. Down here's the part that really matters as far as size is concerned. And that's right on the money there. So we're going to take this back over to the lathe now. I'm going to put this in the chuck, have the center down here, then we're going to round these edges off just a little bit. The original handle had the these edges turned down for about half the length. On this end, the edges are eased just a little bit, and then they're turned down fairly aggressive down here. So we're going to take just a little bit off. I've got the workpiece back in the lathe now. Got it held with that extra stock we had down here. And good and tight in the chuck. Got the center in. I think I'll take just a little more. 20 more thousandths there. Of course, I'm going to do this for the full length. All right, that eased the edges on all four corners, which obviously it should have. Now let's get a indication on the knob end of about where we want to stop our decorative. Just rounding it off down there. That's just to ease where you get hold of it with your hand to engage and disengage the chuck. I think I'll do, that was 60 thousandths, I think I'll do 60 more. All right, I'm happy with that. That's about half and half. Now I'm going to take this round bit that I've got right here and just try to ease into this just a little bit to take care of these corners right up here. I want to just touch. It's looking good. Now what I want to do on this end is screw the knob on there and see how much I need to take down. You probably can't see this, but how much I need to take down, if any, to match this flat that's on the end of the knob here. It don't look like I'm going to need to take down any. Nope. That's a good fit there. So I'll pull that out and show you what it looks like. Well, I need to part this off first and then we'll take it out. We're pretty close to being in business now. So here's our knob threaded in. Got just a little, about half and half on the flats and the round. Remainder up here is flat at 7/16. Now, before this will fit in here, obviously we got to get a round on there. Got to round it off so it'll pivot. And see if it needs any additional cleaning up in there, or maybe just a little extra filing and deburring. So I'll look over at the workbench and see what's next. All right, again, here's our handle. I've gone over to the grinder and removed that tit off the end and eased just two edges on there. All right, hopefully you can see how that's fitting in there now. Again, there was a little bit on this edge where it was originally pulled up on or pushed down on, is worn a little bit beyond the 7/16. But what I'm going to do now is take the transfer punch, transfer this hole right here, and then we're going to do some grinding on this end to put a pivot on there like the original was. If you can tell in the camera, it was offset a little bit off of center, which is going to have to be even more so now because we have a 7/16 deep instead of 3/8, and this was probably originally centered just a little bit offset of center on the 3/8. So our grinding will be a little more aggressive on one side. So I'm going to transfer that mark over and then we're going to do some grinding. All right, not sure that you can see it, but I've got the hole transferred over to here, and the spring pin that's going in is a 5/32. Remember, we drilled this for 5/32, which is 0.156. We want this handle to free spin on that just a little bit. We don't want the pin to pinch on this as well. So I'm going to go with a number 20 drill bit, which is only 5/1000ths larger. We'll try that and see if that goes. If not, we'll drill this a little bit larger. But I'm going to use the wiggler now to locate that punch that I transferred over. Lock the table down right there. And of course, that hole is a little off center because we're going with a 7/16 instead of a 3/8 now. So I'm going to deburr this, and then I'm going to go over to the grinder. There's not a whole lot you can see on the grinder, but what I'm going to do is just put a radius around here, with the radius being a little bit heavy on this side over here. Okay, I've got a drill bit now that I'm using. It's a couple sizes smaller, just to test the grind on. And there's what I meant about the grind. So let's try the pin now. If it's too tight with the pin, we can always take it back out and make the hole a little larger. Of course, I went too far. If you've not seen my video where I made this bench anvil, check it out. All right. So now I think we're ready to go over to the to the surface grinder and install it. But you know what? I think it needs surface grinding. I took the pin back out of the main body of the handle. Got the wheel dressed. And I'll have to use a makeshift handle. And I've got an awful lot to learn about surface grinding. Like how not to pinch your finger when you're doing that. I'll continue to do 2 at the time until I get a complete pass over, and then I'll go 1/1000ths and do I'm doing 50,000 step over at the time. I'll turn that down to 25,000ths at the time for the final cut, final pass. Alright, so now I'm going to do just the final. And this is going to be very little sparking this time. Still got a lot to learn. That looks and feels a lot better than the milled sides. So I'll continue to do that on the other 3 sides and then bring you back when we're ready to put it together. Originally, the body had a somewhat of a seal, but it was all to pieces when I took it apart. Only just the housing of it was left. But I found an O-ring that I think is a pretty good match there. So I'm going to put that in place of it. Got the large side of the tapered pin up. Alright. I think that looks considerably better. I'll play it all in it. I can still kick it out if I got a vise hanging off the edge of the clamping vise hanging off the magnetic vise. So I think we'll call this project finished. Hope you enjoyed it. We'll see you on the next video.